This is a key to worksheet 1 on topic 6, part B. And on this worksheet, you are solving each of these square root equations. And so let's look at number 1. So number 1, we have this problem. Okay, so in 1 we have the square root of 3x minus 2 plus 5 equal 8. Now when solving a square root equation or any radical equation, in this case it's a square root, remember the index, if you don't see an index here it's understood to be 2, so square root. So in solving a square root equation, the first thing you want to do is get the square root expression by itself. So you want to isolate this part here. So let's go ahead and subtract 5 from both sides. And so when I subtract 5 from both sides, I get the square root of 3x minus 2 is equal to 3. All right, so now at this point, I have the square root expression by itself. Now remember, to solve this equation, we have to isolate the variable x. So somehow I've got to remove that square root symbol. And that's an easy thing to do, because remember the opposite of taking the square root is to square both sides. So at this point, I'm going to go ahead and square both sides just like this. All right, so you need to have shown that part. And so the square and the square root are inverse operations, so they undo each other. And so you're left with the radicand. And so the radicand here is 3x minus 2. And so we get 3x minus 2 equals 3 squared, which is 9. And so notice I went from a square root equation or a radical equation to a linear equation. And we all know how to solve a linear equation. So to get the variable x by itself, I'm going to add 2 to both sides. And so when I combine like terms, I get 3x equal 11. And then to divide both sides by 3, I get x to be 11 thirds. Okay? Now I want you to notice something. So remember we said we went from a square root equation to a linear equation. So this real number here, 11 thirds, is a solution to the linear equation. But the situation is this. Is it a solution to the square root equation? Because here's what we got to remember. Whenever you raise both sides of an equation to an even power, and I did because 2 is an even power, and so remember I squared both sides. So that's an even power. Whenever you raise both sides to an even power, you must check for extraneous solutions. And so sometimes we refer to the word extraneous as false. So these are false solutions. Now, keep in mind that 11 thirds is a solution to this linear equation. That's a true statement. You can check it. 11 thirds, 3 times 11 thirds is 11. 11 minus 2 is 9. But you must always check the original radical equation. So we have to check. So you have to check. Whenever you raise both sides in even power, you have to check for extraneous solutions. So let's check x equal 11 thirds. So we're going to go back to the original problem. Always go back to the original. And so the original is 3, the square root of 3x minus 2 plus 5 equal 8. And so in place of the variable x, I'm going to substitute 11 thirds. So I get the square root of 3 times 11 thirds minus 2 plus 5. And I want to see if that's going to equal the other side, which is 8. Well, 3 times 11 thirds, the 3's divide out. And so this product here, 1 times 11 is 11. 11 minus 2 is 9. So this right here becomes the square root of 9. And then I'm adding 5 to that. And the question is that equal to 8? Well, the square root of 9 is 3. And 3 plus 5 does equal 8. So that's a true statement. So 11 thirds is a solution. Okay? All right, number 2. Number 2, we have this. We have, and let me go ahead and do that on another sheet of paper. So this will be number 2. All right, here's number 2. We have the square root of 5x plus 14 is equal to x. All right, so, all right, now remember we have to get the radical expression rather by itself, just like we did here. In this case, though, number 2, it is already by itself. So right away, if I want to get rid of that square root symbol, which you do, you're going to square both sides. So I'm going to go ahead and rewrite this over, and we're going to go ahead and square both sides. And so when I square both sides, just like this, you have to show that part. You have to show that you're squaring both sides. The square and the square root undo each other, so I get 5x plus 14 is equal to x squared. All right. Now, remember when we square both sides and we got to this part here? So in number 1, we went from a square root equation to a linear equation. And solving a linear equation is very easy for all of us. This time, though, I want you to notice something. I went from a square root equation to a quadratic equation. See that x squared? That's a quadratic equation. So to solve this quadratic equation, we have to first of all put it in standard form. And so to put this in standard form, I'm going to go ahead and bring all these terms to the right side, since x squared has a positive coefficient here. That's a positive 1, so let's just bring everything to the other side. So when I bring the 5x term to the other side, basically what's happening, and I need for you to understand that, basically what's happening is that you're subtracting 5x from both sides. And when you do that, and combine like terms, you get 0 here, so you get 14 equal x squared minus 5x. And then finally, you're going to subtract 14, and so you get 14 minus 14 is 0, so you get 0 equal x squared minus 5x minus 14. Now, you didn't have to do all these steps. You could have gone directly from here to here, and almost all of you, most of you, can do that very easily, to go from here to here. Okay? Now, so at this point, you can use the quadratic formula, or and in our case here, it is factorable. So let's go ahead and factor this. It's quicker to factor. And so when I factor this, but again, you can use the quadratic formula. So when I factor this, I'm going to get x minus 7 times x plus 2. All right? And always check. When you factor, always check. Now, some of you may have a little bit issue remembering some stuff about factoring from last semester. So your last semester course was a course where you spent quite a bit of months on factoring. So you may need to go back and review much of that. So if you check it, you get x times x is x squared. The last, negative 7 times 2 is a negative 14. So remember, you're foiling this. And the outer, see, that's a 2x, and the inner is a negative 7x. A negative 7x and a positive 2x is negative 5x. All right. Now, at this point, remember, you're using the zero factor property. So the zero factor property says that when you have 2 or more factors whose product is 0, then one of those has to be 0. So you're going to say each of these is equal to 0. And so notice I went from a square root equation to a quadratic equation, and then from this quadratic equation to 2 linear equations. And so now I get x to be 7 and x to be negative 2. Now you got to be careful. Many students will make the mistake and stop there. But remember what we said. Whenever you raise both sides of an equation to an even power, you must check for extraneous solutions. So you must check. So let's go off to the side and check each of these solutions. So let's check the first one. So let's go ahead and check x equal 7. Remember, you must go back to the original problem. So I'm going to write the original problem over. 5x plus 14 is equal to x. Okay, so in place of x, we're going to substitute 7. So I get the square root of 5 times 7 plus 14, and we see that's going to equal x, which is 7. So let's see if those two sides are equal. 5 times 7 is 35, so I get 35 plus 14, the square root of that, rather. And 35 plus 14 is 49, and the question is the square root of 49 equal to 7? Yes, it is. So that's that one. So right away I can say 7 is a solution. 7 will be a solution, so I'm going to box it up. I'm going to circle it. Let's look at x equal negative 2. So let's check x equal negative 2. I'm running out of room, so let me go ahead and do that here. So let's check x equal negative 2. So again, remember the original problem was this, square root of 5x plus 14 equal x. So in place of x, I'm going to substitute negative 2. So I get the square root of 5 times negative 2 plus 14, and I want to see if that's going to equal x. Now remember x, we're substituting -2. Well, 5 times -2 is a -10. And -10 plus this 14, the square root of that, gives me the square root of 4, which is 2. And 2 is not equal to -2. So that means that this solution here, now listen to my words, this x equal -2 is a solution to this quadratic, but it is not a solution to the radical equation. So that's a false solution. That's an extraneous solution. So I'm going to write the word, this is an extraneous solution, just to remind you that we cannot use it. So our only solution, so in the blank, you will indicate that x equals 7 is the only solution. Okay? All right, so that was number 2. Let's look at number 3. Okay, so in number 3, we have this problem. We have the square root of 4x plus 13 is equal to x plus 2. Okay, now, the difference between number 3 and number 2, you'll see it's almost similar. So you have a radical expression by itself. On the other side, though, notice in number 2, you had a monomial. You had one term here, whereas over here you have 2 terms. Okay, so it's a little bit more work, probably about another 30 seconds or so for you to deal with this side, but it is doable. So the square root expression is already by itself. So at that point, we're going to go ahead and square both sides, just like this. Put both sides in parentheses and square. And then remember the square and the square root undo each other. So now I'm left with the radicand 4x plus 13 is equal to, and then over here, remember what x plus 2 squared means. So x plus 2 squared means x plus 2 times itself. That's what that means. And so now I'm multiplying two binomials, so I'm going to go ahead and use the FOIL method to to multiply this out. So x times x, so the first x times x is x squared. The outer is 2x. The inner is also 2x. And the last, a positive 2 times a positive 2 is a positive 4. And so when I combine like terms, I get x squared. 2x plus 2x is 4x. And then plus 4. So this right here, this product is this trinomial, which I'm going to write here. So it becomes x squared plus 4x plus 4. Okay? All right, so again, notice I went from a square root equation to a quadratic equation. So to solve this quadratic equation, I need 0 on one side. So let's go ahead and bring both of these terms to the side since x squared has a positive coefficient on the right side. So I'm going to go ahead and subtract 4x from both sides. And again, you can skip this step because most of you know what to do without having to do this part here. But this is really what's happening though. So 4x minus 4x is 0, so you get 13 equal x squared. I want you to notice that 4x subtract 4x is 0. So you get x squared plus 4 over here. And then the next step is to subtract 13 from both sides. So when I subtract 13 from both sides, 13 minus 13 is 0, equal x squared minus 9. And so notice I have this quadratic equation, x squared minus 9, which is equal to 0. And then we got to factor this. So I want you to notice that here, when I factor this quadratic equation, I had 3 terms, all right? And so I used trial and error from last semester to help me to factor this. Last semester, notice that here you only have 2 terms. And I want you to notice that you also learned last semester about the difference of 2 squares, which is what this is. This is the difference of 2 squares. So you can factor this as x minus 3 times x plus 3 equals 0. And then you set each of these factors equal to 0. So you get x minus 3 equals 0, x plus 3 equals 0. And so you get these 2 linear equations. And so x is equal to 3, x is equal to negative 3. Now before you say those are your solutions, remember you you raise both sides to an even power. So you have to check for extraneous solutions. So let's go ahead and do that. So let's check x equal 3 first. So x equal 3. So we go back to the original problem, which is the square root of 4x plus 13 is equal to x plus 2. And so in place of x, I'm going to substitute 3. So I get the square root of 4 times 3 plus 13. And I want to see if that's going to equal 3 plus 2. Because remember saying x is 3, so 3 plus 2. Well, 4 times 3 is 12, so I get the square root of 12 plus 13. And 12 plus 13 is 25, so I get the square root of 25, which we know is 5. And is 5 equal to 3 plus 2? Yes, it is. So this is going to be a solution. So I'm boxing this off. I'm circling this solution. Let's check negative 3. So when we check x equal negative 3, the same thing. You go back to the original problem, which is this. 4 times, 4x plus 13 equal x plus 2. So in place of x, I'm going to substitute negative 3. So I get the square root of 4 times negative 3 plus 13. And I want to see if that's going to equal negative 3 plus 2. Well, 4 times negative 3 is a negative 12. And negative 12 plus 13, the square root of that, is a 1, square root of 1. And the square root of 1, we know, is 1. But negative 3 plus 2, though, is negative 1. And notice that 1 is not equal to negative 1. They're not the same thing. So now we know that this x equal negative 3, which does satisfy this quadratic equation, because a negative 3 times a negative 3 is a positive 9, and 9 minus 9 is 0. So it is a solution to this, but it's not a solution to the square root equation. So this is an extraneous solution. And so therefore, the only solution you would indicate in the blank would be x equal 3. All right? So that's number 3. Now before we go into number 3, I want you to notice something. When we got to this point, let's suppose you did not know that you could factor this. Let's suppose you didn't know that. And you said, well, since it's quadratic, I'm going to go ahead and use the quadratic formula. Okay, so let's use the quadratic formula because I want to show you something. I want to remind you about something from last semester, because last semester you did solve quadratic equations because it was on your final exam. So let's go ahead and do this one again. So we're going to solve x squared minus 9 equals 0, x squared minus 9 equals 0, using the quadratic formula. So just to show you what to do. So remember, when using quadratic formula, you have to look at the quadratic equation in this form: ax squared plus bx plus c equals 0. And then the quadratic formula, remember, is the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so when using quadratic formula, one of the things that we indicated would be a good idea is to label a, b, and c. So remember, a is the coefficient of the x squared term. So in this case, a is 1. b is the coefficient of x, of the x term. But notice there is no x term here. So you see that x squared minus 9 equals 0? If you think about it, that's really this: x squared plus 0x minus 9 equals 0. Do y'all agree that this is the same thing as this? So if you look at x, the coefficient of x is 0. So b is 0. And then c is your constant, which is negative 9. So I'm going to substitute these values of a, b, and c into the formula. So I get x equal, and remember this says the opposite of b, so b is 0, so the opposite of 0 is still 0. Plus or minus the square root of b, which is 0 squared, so notice I put that in parentheses, squared, minus 4 times a is 1, times c, which is negative 9, all divided by 2 times a. And so then this becomes 0, plus or minus the square root of 0 times itself is 0. Now a negative 4 times 1 times a negative 9 is a positive 36, all divided by 2 times 1, which is 2. So this becomes 0, plus or minus the square root of 0 plus 36 is 36, all divided by 2. And remember, this 36 is a perfect square, so the square root of 36 is 6. So this becomes 0 plus or minus 6 divided by 2. And I want you to remember something, that 0 plus or minus 6 is the same thing as just plus or minus 6 divided by 2. And so now we have these two rational solutions, 6 divided by 2 and negative 6 divided by 2. So a positive 6 divided by 2 and a negative 6 divided by 2, which gives us 3 and negative 3. So you can use the quadratic formula instead of factoring to solve this quadratic equation. All right, so that was number 3. And then finally, let's look at number 4. So number 4, we have this problem. Okay, so we have the square root of 5x minus 9 is equal to x minus 1. So it's very similar to number 3. We're going to go ahead, since the square root expression is by itself, we're going to go ahead and square both sides. And so when I square both sides, the square and the square root into each other, so I'm left with the radicand 5x minus 9 with the expression 5x minus 9 equal. And then just like the previous problem, we're going to go off to the side and we're going to figure out what x minus 1 times itself is using the FOIL method. So x times x is x squared. The outer, x times a negative 1 is a negative x. The inner, negative 1 times x is a negative x. And the last, a negative 1 times a negative 1 is a positive 1. When I combine like terms, I get x squared. A negative x and a negative x is a negative 2x, and then plus 1. So this x minus 1 squared, this binomial squared, is going to be this trinomial right here. So that becomes x squared minus 2x plus 1. And just like the previous problem, when we got to this point right here, we went ahead and brought both of these terms to the other side. So basically, you're going to subtract 5x from both sides, and you're going to add 9 to both sides. So let's go ahead and do the steps. So you're going to get 5x minus 5x from both sides. This is 0, so you get negative 9 equal x squared. A negative 2x and a negative 5x is a negative 7x, and then plus 1. And then finally, you're going to add 9 to both sides. And so when I do that, negative 9 plus 9 is 0 equal x squared minus 7x plus 10. And so now I have this quadratic equation. I have the quadratic equation x squared minus 7x plus 10 equals 0. That's now in standard form. And it is factorable. If you wanted to, you could use a quadratic formula. If you use a quadratic formula, a is 1, b is negative 7, and c is a positive 10. So you may want to do it both ways just to verify that you are getting the same solution. So let's go ahead and factor this. When I factor this, I'm going to get x minus 5, x minus 2. And so that's how this factors. And again, you can check this using FOIL. X times x is x squared. A negative 5 times a negative 2 is a positive 10. The outer is negative 2x. The inner is a negative 5x. And when you add them up, you get negative 7x. And now remember, you're going to use a zero factor property because you have two factors here whose product is 0. So one of those has to be 0. So x minus 5 equals 0, x minus 2 equals 0. And then when you solve these two linear equations, you get x to be 5, x to be 2. And now let's go ahead and check, because remember what we keep saying, that when you raise both sides to an equation to an even power, you must check for extraneous solutions. So I did do that here. Notice I squared both sides. 2 is an even power. 2 is even. So let's go ahead and check. So let's check the first one. So we're going to check x equal 5. And remember, you always go back to the original. So the original is this one. The square root of 5x minus 9 is equal to x minus 1. So in place of x, I'm going to substitute 5. So I get the square root of 5 times 5 minus 9. And I want to see that's going to equal 5 minus 1. Well, 5 times 5 is 25. And then 25 minus 9 is 16. So that's square root of 16. And over here, that's 4. And the question is the square root of 16 the same thing as 4? Yes, it is. So that implies that 5 is going to be a solution. So let's look at the next one. So let's check x equal 2. So when I check x equal 2, it's the same thing in the original problem. I get 5x minus 9 equal x minus 1. So in place of x, I'll substitute 2. So I get the square root of 5 times 2 minus 9. And I want to see if that's going to equal 2 minus 1. Well, 5 minus 2 is 10. And so I get 10 minus 9, the square root of that. And then 10 minus 9 is 1. And the question is the square root of 1 the same thing as 1? And the answer is yes. So both of those are solutions. So I don't have any extraneous solutions here. None of them are false. So both of those are solutions to the quadratic equation, and they are also solutions to the square root equation. All right. Now before we end this, because that was the last problem, don't always think, because some students when they first study this topic, they always seem to think this. They always seem to think that whenever you get a negative, whenever you solve this and you get a negative value, then it automatically you cannot use it. That's not true. That is not true. Sometimes, depending on what your square root equation looks like, the negative will be a solution. So don't always assume, at this point in your study, don't always assume that negatives will always be extraneous. All right, so that's not a true statement. Okay, same thing with positives. It turned out in these problems that the positives were solutions. They were not extraneous. It could be in some other problems where a positive value for x is the false solution. Okay, so that's why you have to check. You must check. Okay, so that is going to take care of the key to the worksheet on topic 6, part B.